So today we will try to understand the very fundamental thing about the statistics, and that is the fuel of statistics. That what is the data, what kind of data. We have to understand this very basic concept, and I am very much certain that if you will understand this concept, so this will help you for the further lectures in the workshop. So the topics are very basic, but very important. But before moving to the topic, I would like to ask you this very simple question, that why do we need statistical calculation? So you can answer me in the chat box for this particular question. Why do we need statistical calculation? You can write down using your chat box. So I'm getting that for making appropriate prediction about phenomena, to analyze data, to interpret the data for better understanding, for inferring data, for concluding large amount of data, to interpret, to represent the data, to test hypothesis. Okay, so easy interpretation. So lots of input I am getting from my participant. But let me tell you that these are the consequence of statistical calculation. Means all these which are being written, these are the consequence of statistical calculation. This is not why we do statistical calculation. We do statistical calculation because of this term, because we have variability. So whenever we measure something and we note down its value, if those values are different, then we try to understand why the variation is there in that measurement. For example, if we are measuring the birth weight of a newborn child, and the birth weight of the newborn child are different, say some births are around 2.5 kg and some births are around 3 kg and 3.5 kg. So we can see that in this particular measurement, birth weight of the baby is different. Now, as a researcher, we try to understand why this variation is there. What are the causes of this variation? Whether this variation is because of the duration of the pregnancy, whether this variation is because of the background characteristic of the female. There are lots of factors because of which this variation is there. So as a researcher, we do statistical calculation to understand the variability into the data which is present over there. So let me make a statement that variability is the mother of statistics. If there is no variation in the data, there is no need of statistical calculation. And whatever the thing which you people are writing, that is the consequence of statistical calculation. So this is the very basic things, that whenever we measure something, that particular measurement have got variability. To understand that variability, we need statistical calculation. So since variability into the data is the most important and fundamental part of statistical calculation, so as a researcher, we should understand that what are the various sources of variability, or where does the variability come into the data. And you can, whenever you measure something, you try to correlate your example with this particular points, which I am going to discuss with you. So the variability come into the data from these three factors of interest. So the first factor of interest is the conditional factor of interest. And the second factor of interest is the measurement process. And the third factor of interest is the experimental material. So let me try to explain these three points with an example. If a researcher wants to measure the blood pressure of the patient who are coming into the OPD. So this is the factor which a particular researcher is measuring, blood pressure of the patient. Now, the blood pressure of the patient, certainly you will have different values. If you will measure the blood pressure of the patient, you will get different values. So the first source of variability is the conditional factor of interest, means whether the patient is hypertensive or the patient is not hypertensive, or he is suffering from some certain disease or is not. So this is the conditional factor of interest. Now, the variability into the blood pressure can also come from the measurement process, means how the healthcare worker is measuring the blood pressure of the patient, what procedure he is applying, whether he is following the strict guideline to measure the blood pressure of the patient, or just he is measuring the blood pressure of the patient. Any patient just running to his room and he's just measuring the blood pressure. So he should follow a strict protocol for measurement of this blood pressure. Otherwise, the source of variation can also come from this way. Third source of variability is the experimental material. You can see that the experimental manual blood pressure machine or this electronic blood pressure machine, the values of the blood pressure. Okay, so so this is the thing that I try to tell you, that statistical calculation is because of the variability. And variability, there are three sources of variability. One is the variability because of the conditional factor of the interest, means the data is showing the variability. So the population must have inherit some conditional factor of interest. That is, you can say that if the patient is hypertensive, so obviously his blood pressure will be on a higher node. And there are various other disease factors because of which the blood pressure will be on a higher node. But the variability can also come from the measurement process, or by which material you are measuring that particular thing. So as a researcher, what we should focus on, that variability because of the point number 2 and 3 should be minimum whenever we are doing any research. So in this particular, we have to understand that there are three sources of variability. As a researcher, we always try to find out the variability can come into our data because of the planned or the systematic. Means this is our research question, that the blood pressure in the patient will be high because he is hypertensive. So this variability that we have planned, we have hypothesized, but the variability into the data can also come from the chance or the random error or unplanned systematic. Means there are various co-factors because of which the blood pressure of the patient can be on a higher node. So we have to understand that what kind of variability is existing in our data, and these statistical calculation is going to help us answering in this particular set. So in particular, decision making on the basis of the data. So you have to understand that this is, you can say, the target population. The target population is the up to class 5th, all the students who are going to the school up to class 5th. And we want to know that what proportion of them are suffering from asthma. So this is the particular thing that we want to estimate. Now, we can estimate this by using the proportion with asthma, just by taking the sample from this population, and from this sample we estimate what proportion of the children are suffering from asthma. And this particular sample is going to give us an idea that what true proportion of children are there into the. But while doing this decision-making process, what is very important thing is that the data. Okay, if the data is the only weapon for us, if our data collection, if our measurement process, the way we are taking the data from the population is not appropriate, so obviously we are going to make wrong research or wrong interpretation. So this data is very important weapon in statistical calculation. So today we try to understand that what are different kind of data in statistical research. So now you can see this particular slide where we try to decide that whether the data is of dichotomous variable, or the data is categorical, or the data is metric variable. So whenever you see a data on the particular characteristic of the patient, either that data will be dichotomous variable, or that data will be categorical, or that data will be metric variable. So how you will understand that your data is dichotomous variable? So if that particular variable have precisely only two distinct valid values, say yes or no, whether you smoke, yes or no, whether the patient is died, yes or no. So if a particular question have only these two kind of information, so we can say this is a dichotomous variable. Another kind of data is termed as categorical variable. So what is the difference between categorical variable and metric variable? If the data have got a fixed unit of measurement with it, then it is a metric variable. And if the data do not have fixed unit of measurement with it, then it will be a categorical variable. If you measure the height of the patient, so height of the patient will be 160 centimeter. So this centimeter is the unit which is associated with that particular measurement. So such measurement is a metric variable because it have got a unit with it. But if you measure the place of residence of the patient, so either he will be urban, rural, or town. So this particular unit of do not have any unit of measurement, so it will be a categorical variable. So now this categorical variable is also of two kinds. One is the nominal variable, another one is the ordinal variable. What is nominal variable? If your categorical variable cannot be kept into any order, so it will be a nominal variable. If your categorical variable can be kept into order, so it will be an ordinal variable. So if you can take this example that whenever a patient who is going to come to the COVID hospital, so that the doctor who is sitting into the PRO office, he is asking what is the condition of the patient, whether the patient is on room air, or the patient required oxygen, or the patient need ICU. So you can see that these are the categories of the patient. So if you respond according to it, so all these are categorical variable, but you can say it have got some ordering into it. By this, the doctor is able to know the severity of the patient. So ordinal variable are such variable in which there are certain kind of order. So this statistical calculation, usually it uses four general approaches. One is the descriptive statistics. Another one is the statistical estimation, statistical hypothesis testing, and statistical modeling. So today we will be discussing the first part of this particular aspect, descriptive statistics. This point number 2, 3, and 4 will be discussed later into this workshop. So now, as I told you that if your data is nominal data, okay, nominal data is a categorical data. So you can see the gender. So gender is either male or female. How you can present this nominal data with the help of the table. So you have to simply write down gender, and then here you have to write down male and female. And then here you have to write down the number of male and the number of female, and the top you have to write down what is the total number of the babies. In terms of a better understanding, you can convert these numbers into the percentage. So you can see that the type of color the babies are born, brown, dark, blonde, and red. So these are the categorical variable, and this is the total number of babies which are born into the hospital in a month, and this is the number. Now you have converted this number into the percentage. So by this percentage, you are able to understand that more than 50% of the babies are born with the brown color, and only 4.2% of the babies are born with red color. So it is better to convert these number into the percentage so that the reader is able to understand the data more precisely. Similarly, if your data is an ordinal variable, the same thing you can do. You can simply write down the various categories of that categorical variable, and in front of them you can write down the numbers, and at the top you can write down what is the total number of and the two group. So this is how you can present your data. Now this particular example, you can say parity and gravida of the woman. So these are the questions which are asked to the 100 women into the OPD of maternal reproductive department, and this is the response of the woman. How many parity? 0, 0, 2. Now my question is whether this particular variable is categorical variable or metric variable. Write down your answer into the chat box. Whether this particular variable is a categorical variable or metric variable. Great. All those who have written the metric variable, they are correct. And all those who have written the categorical variable, that is not correct. Why? Because you can see that how many children? So he will say three parity. With 3, the unit is parity. Okay. So that's why it is a metric variable. This is not a categorical variable. Okay. So if the metric variable is there, now this particular metric variable, why people got confused? This is a discrete metric variable. Okay. This kind of metric variable is discrete metric variable because you can count the possible values on your fingers. So for such discrete metric variable, you have to present the data like this. This is the frequency distribution of the parity. Here you have written on the parity and the number of women of 0 parity, number of women of 2, 1 parity. In this way, this is the frequency distribution of the parity of 100 women, which you have seen into the OPD. So this metric variable is termed as discrete metric variable because all the possible outcome you can count on your finger. For example, if a woman coming to your OPD and you ask how many children that particular woman might have, the next woman who's coming to the OPD, how many children that woman may have. So all the possible answer you can count on your finger. But what is the height of the woman? Can you count all the possible outcome on your finger? You cannot count all the possible outcome on your finger. So such metric variable are continuous metric variable. I hope you understand this particular concept. So how to present the discrete metric variable? You can see this example. This is the frequency distribution of efficacy of biodegradable stunt with durable stunt. So you can see total number of 1 stunt, 2 stunt, 3 stunt. So this is a discrete metric variable. And this is the frequency distribution of in these 2 categories. Okay. Now, another example is the continuous metric variable. So the continuous metric variable here, you can see cumulative frequency for the birth weight of the babies which are born to the. So you can see that this, how these birth weight are presented over 1500 gram to 1901 and then 2000 to 2499 and like this, how this is going, and the numbers are then presented. So this is the frequency distribution of this, and then the cumulative frequency distribution. This is 2 plus 5, 7, 7 plus 27, 34. In this way, this is the cumulative distribution, and you can convert obviously this cumulative distribution into the frequency variable. Now, describing the data with charts. So if your data is nominal or ordinal, you can present your data with the help of the pie chart. Here you can see this example, incidence of burn by age. So here you can see that this is the ordinal variable, and the data can be presented with the help of the pie chart. You can also present the data of this by simple bar chart. categorical variable can also be presented by simple bar chart. So bar chart, what is the most important thing in the bar chart? On the x-axis, we have got the different categories, and on the y-axis, we have its frequency. And the great thing is that you might see the gap between these bars. That's why it is termed as bar charts. So the categorical variable can also be presented with the help of the bar chart. There is also, if there are two groups into the categorical variable, you can present them with the help of the clustered bar chart. So here you can see this is the lowest and the highest, and this is the two kind of the dose. So the pain level lowest and the pain level highest and you can compare them with the help of these two kind of doses. So this is termed as the clustered bar chart. Now, a very important and pertinent diagram, that if your data is a discrete metric data, such data should also be presented with the help of bar chart. It should not be presented. You can see the parity of the woman. So it should be presented with the help of the bar chart. So if your data is discrete metric data, you should present your data with the help of the bar chart, not with the histogram. Histogram is only prepared for the continuous metric data. Okay. So what is that? There is a continuity into the bars. So it becomes the histogram. Okay. So you should take very important note that if your data is a discrete metric data, then you should prepare a bar chart. And if your data is a continuous metric data, then you should prepare this histogram. Okay, so these questions are usually asked into the various interviews so you should take this. Now, this is very important plot into the statistics, and that is termed as the box plot. Now, what is this box plot actually do? Box plot is actually, you can see that this box plot have got a box. This is box, you can say, and these lines are termed as whiskers. So this is box and whisker plot. What is this lower is the lower value. This upper one is the highest value of the data. And this particular line is the first quartile. First quartile is something below this 25% of the observation and above this point 75% of the observation. Similarly, this dark line is the median, or below this 50% of the observation and above this 50% of the observation. Similarly, this upper quartile Q3, below this 75% of the observation and above this 25% of the observation. So this box plot actually gives the reader the distribution of the whole data, that how the data is distributed. So these are the two box plot. One is the control and another one is the non-agiospermic long-term survivor of the childhood cancer. And you can see that there is a significant difference between the distribution of these two data. That's why this p-value is also coming out to be significant. The third quartile of this is 50, and the third quartile of another one is around 25. Okay, so in this way, the reader is able to understand the whole distribution of the data just by reading this particular graph. So you can see such kind of table into the research articles, and in the same way, you should also try to present try to prepare your data. Here you can see the first column is the variable, and here it is written age, and then social class, then number of children, then age at birth of the first child. So, and here in those two groups are there. Yeah. Similarly, here you can say the maternal age, and the maternal age is classified into the categories, and then again maternal age is classified into some another categories, parity, number of cigarettes, multiple pregnancies. So how these data are simply presented over here. You can see this another example. Here this age bracket में years, and then sex, categorical variable. So data is presented in the numbers, and here in the bracket, the percentage is given. So you can say number of children in bracket percentage. Okay. Home number, number of rooms, and then length of the hair, number of children, long, mid, long, short. So all the categorical variables are presented with number. In bracket, they have given the percentage, and all the, you can say this metric variable are given with the mean, and in bracket standard deviation. Okay. So what are the number, percentage, and proportion? So one thing that you can do with your data is simply you can count it. And for example, you can count the number of men and women. You can count the total number of individuals with a particular kind of blood group. So usually if your data is the categorical data, so you can count them and write down what is the frequency of various categories. Now we'll try to understand that what are the various descriptive measures that we can use for summarizing the data numerically. Up to now, we were discussing that how we can present our data in the table, what kind of graph and figure that we can prepare for our data. Now we try to understand how we can summarize our data numerically. So the first type of measurement is the mode, that is the measure of central tendency. So mode is very rarely used in research article. What is mode? If you will see, mode is something which is coming very frequent. Okay, here you can see that the delivery method for 22 babies are given below. What is the modal delivery method? Means by which method most deliveries are coming are happening into a particular hospital. So in this case, you can write down what is the mode of the data. Now, what are the other properties of the mode, and why it is not very often used? That there can be more than one mode. It is not usually useful with the metric continuous data, where no two values may be the same. Imagine try to find out the modal birth weight from the example that we have discussed earlier. It will be very difficult to find out the modal birth weight of a continuous variable. Similarly, the mode is not useful with the discrete metric data when the number of values is very much large. But the mode have only advantage that it is very much easy to understand. Means the value which is coming the most frequent, it is the modal value of the data. Another measure of central tendency is the median. So what is median? That we can say that if we arrange the data in ascending order of size, the median is the middle value. Means half of the value above this, half of the observation will be above this value, and half of the observation will be below this value. Such value is termed as median. Okay. So therefore, we can say this median is a measure of centralness of the data. Here you can see the example. This is the age of the 5 colleagues, 30, 31, 32, 33, 35. So this 32 is the median value of this particular data. Now, what if instead of 5 observation, there will be 6 observation, 30, 31, 32, 33, 35, and 36. So you have to take the mean of these two middle value, 32 and 33, and 32.5 will be the median of this particular data set. And just below this, you can see if instead of 36, if the last observation is of 96, even though this data set have got the same median 32.5. Okay. So by this example, you can understand that this is the advantage of the median, and this is also the disadvantage of the median. Now, we'll try to understand the mean, which is mostly used and very much easy and simple to calculate that this mean, or you can say this arithmetic mean, which is the statistical name, it is very commonly used on also termed as average. What we can do, we have to just all the observation and divide it by the number of observations, so we'll get the mean. It uses all the information of the data because it is using all the information, but median is not doing so. Median is just using the middle part of the data. But if your data is skewed, so your mean will be on a positive side. Means if your data is just, if you can understand this previous example here, the mean of these two data set will be different. Because of this 96, the mean of this data will be on a higher end. So that's why, because of this outlier, the mean gets affected. So this is the advantage, that it uses all the observation, and because of this, it is the disadvantage of the mean, that it gets affected by the outliers. So as a consequence, the mean on some occasion might be unrepresentative of the general mass of the data. So now, to summarize, if you're, first of all, try to understand, sorry, try to understand what is your type of variable, whether it is a nominal. If it is nominal, so you can give the output with the help of the mode. You should not give median or mean into that as a measure of location. If your data is ordinal, you can give mode, you can give median, but you should not give mean, because ordinal data do not have got unit with it. So you, for finding out the arithmetic mean, you have to add them, and adding the categorical variable is meaningless. So mean should not be given if your data is ordinal. If your data is discrete metric data, so you can find out mode. You should go with the median if your data is skewed, and you should go with the mean if your data is normally distributed. Similarly, if your data is metric continuous, so you can find out mode. No, never. You should not find mode if your data is metric continuous. You should calculate median if your data is skewed, or you should go with median if your data is normally distributed. So the main thing to remember is that mean cannot be used with the ordinal data because they are not real number, and the median can be used for both ordinal and metric data, particularly when the metric data is skewed. So these 2 points are very much important for all of you to understand and remember. Now we will discuss how we can describe the variability into the data numerically. So the first and the very simple thing that we can do, that we can just give the highest and the lowest value, and that is termed as the range. So the range is the distance from the smallest and the largest value. And the range is not particularly affected by skewness, but is sensitive to addition or removal of the outlier value. Now, what if outlier is present in your data? Then this range is not a good measure of variability of a data. Then in such case, we should go with the quartiles. So one problem for the range is that sensitivity, that we can divide our data into the 4 equal parts, and that's why it is termed as quartile. So what is Q1? Q1 is that value below which 25% of the observation and above this 75% of the observation. Similarly, what is Q3? Above Q3 25% observation and below Q3 quartile 3. And interquartile range is simply Q1 and Q3. So this interquartile range is not very much affected by the outliers. And when your data is skewed or containing outliers, so you should give interquartile range as a measure of range. So this is the method by which interquartile range can be found. So, and this is the box plot which I've already discussed. So I will not discuss this. Now we'll try to understand variance and standard deviation. So if your data is, you can say, normally distributed, then hello, बस बताएं निकला. So can take this example to understand. Now, standard deviation or variance you should give when your data is not skewed or it is near to the normal distribution. So what is this? So you can see that this is the age of these 5 students or 5 colleagues, 23, 34, 36, 13, 29. So we have written these and then we have added this 152. 152 divided by 5 will give us the mean as 30.4. Now we want how much dispersion is existing is data. So what we try to do, we just try to find out the difference of all these observations from the mean. So simply we subtracted all these observations from the mean and we get minus 7.4, 3.6, 5.6, minus 0.4 and minus 1.4. So if we find out what is the average distance of all these values from the mean, so it will give us an idea how much dispersion is there into the data. But finding out the average when we are going to add, it will come out to be 0. And this is the property. Whenever you will add this dispersion, it will always be 0. So what they simply do, they simply square it. Okay, square of minus 7.4 is 54.76. Okay, so similarly, squaring it and then taking the average of it. So 101.2, divide 101.2 by 5, so it is 20.24. So this is the variance. Because the sum of all these are coming 0. So what they simply do, just they simply take the square of all these distance. Because some of them are positive, some of them are negative. When we'll add all these, it will become 0. So remove this negative sign, just square it. So we square all the distances and take the average of it. So it is termed as variance. Because we have taken the square of average, so for standard deviation, we have to take the square root of this 20.24. So that's it's become the standard deviation 2.24. So this is the variance and standard deviation are the same thing. Just the square root of the variance is the standard deviation. Now, summary measure of the spread or the measure of the dispersion. So if your data is nominal, you should not give range, neither you should give IQR, neither you should give standard deviation. If your data is ordinal, you can give the range, you can give the IQR, but you should not give the standard deviation. If your data is metric, either discrete or continuous, you can give range if outliers are not there. You can give outlier if your data is skewed, and you should give standard deviation if your data is normally. So here you can see that this is the SPSS statistical package for social sciences, and IBM is the company which is preparing this software, maintaining this software. And this almost looks like it have got two windows, 2 panes, I can say. One is the data view and another one is the in the variable view. So this is the data view. When I click on the data view, you can see that this will look like an Excel sheet. And if I come to the variable view, you can see it will just gives us the description of the variable. So now to understand this particular aspect, all of you are very much aware about the Excel sheet. So let me open an Excel sheet and try to enter a data. So the first data set is the name, age, place of residence, height, gender, and mobile number. Okay. So the name is Ram. Age is 32 years. Place of residence is, you can say, ruler. Height is in centimeter, 160 centimeter. Gender is male, and mobile number is 987644321. Another one you can say SH in Shyam. His age is 42. Is urban. Height you can say is 175 centimeter. Gender is also male, and mobile number is 76543211. Like this. Okay. Sita, Geeta, 35, ruler, 154 centimeters. She is female, and anything I am just entering as the Geeta is 41, urban, 160 centimeter, female, and this is his mobile number. Now, this is a, you can say this list can be a bit, maybe a bit bigger, but this is how this data set is there on an Excel sheet. Now, if the same data set we want to enter into the SPSS, okay, so what we have to take care? So we have to take care all these variables. Now the first variable is name. So whether it is a nominal variable, ordinal variable, metric variable, what kind of variable it is. So it will be a nominal variable. Another is age. So I will just open my SPSS and I will go into the variable view, and the name of the first variable is name. What is the type? So the type is string. Width, I can increase the width to 20. Decimal is not there. And here you can describe. So here name of employee. Okay. Now values are not there. Missing, and this is the, then most important, what is the measurement? So measurement is the nominal. So another variable is your age. So what you can do here, you can type age. Now what is age? So age is a numeric variable. Okay. What is the width? 8. What decimal? It do not have any decimal, 0. You can write down here, describe this age of employee. Okay. And then measurement level. So it is a scale variable because the age of the employee is in years. So here you can write the age of the employee in completed years. Then what is the third variable? What is the third variable? Third variable is place. Place of residence. So here I am writing place. Now it is numeric, very good. And it will be 0. Here I am writing place of. Now this place of residence is urban and rural, and it is a categorical variable. So here I will put nominal, and then here in the values, if I'll click on the values, I will give value 1 to urban and 2 to rural. And okay. So this is a categorical variable, and I will give 1 to urban and 2 to rural. Similarly, another variable is height. So again, I will keep another variable, height. Height is again a numeric variable. Here you can type height of employee. Values will be none, and this is your scale variable. Here you can the height of the employee, here in bracket you can in centimeter. And then what is the next value? Next value is the gender. So again, here you can type gender. Gender is numeric. Decimal is not there. Here you can type the gender of employee. Values you cannot give. Yeah, in the values you can type one for male and two for female. Click OK. And here you can type it is a nominal variable. Instead of scale, it is a nominal variable. And last one, which I have taken as example, is the mobile number. Okay. So here I will type MOBILE, mobile. Try to, what you have to take, one thing which you have to take care is that you should not keep any gap between the names. Okay. So just put underscore, mobile underscore number. Yes, it is numeric and it is of 10 place. So this is MOBILE, mobile, NUMBL number. And here it is, here you can say it is target both non-partition spread. So it is none, you can say now. Okay. Now, if you all go to the data view, now you can see how these variables are here. So what I'm trying to say that you simply typed into the Excel these variable and just started entering the data. But in the Excel, in the SPSS, you have to define your data name. What is this type? For example, name is always a string variable. It is not a numeric variable. Then you have explained what is this name of what? This is the name of the employee. There is no categories into the name, so values will be none. And what is this measurement level? It is a nominal. So this measurement level that I've discussed into the talk is defined over here. Another variable is the age. Here in the label, I have described what is this age. So this is the age of the employee into the completed year. This facility is not available into the Excel. Similarly, another variable name is the place. Here I have described place of residence of the employee. And then since this is a categorical variable, so one stands for urban. Here you can see one stands for urban and two stands for rural. Anything you can give. You can also give 0 and 1 or 2 or 3, any numbers you can give. So here just I have given 1 for urban and 2 for rural. The categorical variable. Same for the height, gender and mobile number. So this is the variable view in which the variable, its type, whether it is numeric, string, how much width it will take, label will describe what actually this variable is, values, if there is are the categorical values, the values are notation in the form of the number, and then very important, what is the measurement level of these variable. So when we go to the data view, so simply what I will do, I will simply copy, right? No, yes, I will copy the name and this copy. And I will paste it here. Okay, so you can say name and here place. So for place, I have to enter rural, urban, rural, urban. Okay, so here I have to rural. Another one is urban, rural, urban. Here I can copy the height, and simply I will paste. I can paste the item. You can enter just as you have entered into the male. Just type male, female, female. I have to copy the mobile number. Just copy the mobile number, Control C and paste it here. So in this way, you can do the data entry into the SPSS. So this is the first step, how you can do data entry into the SPSS. Okay. So if your data is already in the Excel, here you can see if this is the Excel, and I'm saving this data onto the desktop, and I'm keeping this the name of this data as test. Okay, and I'm saving it. Now I want to call this data from, so I will go to the SPSS file, open. Here you can also see the import. So I will go to the file, open data. Now where my data is into the Anup Kumar, and in the Anup Kumar it is in the desktop, and in the desktop it is not, file type is Excel. So I will go here and I will select Excel. So I will open it. So when I will open it, the preview of the data is shown like this, and I'll click OK. Now you can see the same data is now called from SPSS, from Excel to SPSS. And if I'll go to the variable view, here you can see the variable view is the name, string, and it is nominal. Another variable age, it is numeric, and it is, but labeling is not there. Okay. So labeling you have to do by your own. Another variable place, and place is, it is taking as a string. Okay. Why it is taking place as a string? Because in your Excel, you have written place as urban and rural. Okay. But this is not the correct way of putting the data. So you have to convert this data into the, what I can say, nominal variable. Here it is nominal variable, but this nominal variable is not proper for analysis. Similarly, for gender, they are also saying that it is string, and mobile number numeric, so it is no problem, but it is not a scale. It is the nominal. Mobile number is not a scale variable, it is a nominal variable. Now, what you can do in case of gender and place of residence, here you can see that A is coming here. Nominality is there, but A is coming there because it is a, so you have to convert this variable. How you can convert this? So for converting this, you should go into the data. No, for converting, you should go into the transform and record into the same variable. What you have to record? You have to record place, old and new values. Okay. What is your old value? Old value is ruler, and new value is 1, add. Old value is URBN, urban, and new value is 2, add. Continue. Okay. So now you can see this urban ruler is now converted into 1212. Okay. Now you have to go to the places, and now you can convert this into the numeric. Okay. Now this place is converted into the numeric, and here in the values, you can write down 1 as urban and 2 as ruler. So in this way, this nominal variable, if you'll come to the variable view, data view, you can say now this, you can see the difference between this place, variable place, and variable gender. You can see small a is still coming here in the gender, but in the place now it is no. And if you'll just click on this, so you can see it is 1 to 1 to n, but here nothing is changing. So you have to also convert this gender into numeric form. How you can do? Again, just go to the transform, recode into the same variable, just reset it. Now put gender over here, old and new values. Put M for 1, add, and put F for 2. Continue. Okay. Now this have converted this 1122, and then again go to this. Now you can convert gender. Now it is not a string; it is a numeric value. Okay, and then go into the values. Give 1 for male, add, and 2 for female, add. Okay. So this is how you have converted when you call your data from Excel to SPSS. So this kind of changes or modification you should do into your data before proceeding for further analysis. Okay. So now there are various other files from where you can export your data. It is not the Excel. If your data is CSV format, that can also be exported text format. If you're doing analysis into the SAS, Stata, DBS, Lotus. So all these forms or type of data can be imported into the SPSS for analysis. Okay. Now I will take data and try to show you some okay. Yeah, I've done the preparation. Actually, the only problem is that this is not my laptop, so I'm just searching for. Searching for a data with which we can do any kind of analysis. PMC. So here you can see that this is a data set, and this is the name of the first variable is the age at baseline, because they are doing some kind of follow the first time when the patient is coming to them. So it is the age in month actually. When you go to the variable view, look, they have not written, they have not explained their level. Means the person who have sent me the data for the analysis, it didn't explain what actually it is. It's just written age at the baseline. But by memory, I know that this is the age of the children in months. Okay. Now I want to, you can say, present this data. How I can present this data? So simply I will go for presenting this data. I will go to the analyze and then go to the descriptive statistics and go to the explore. Okay. And then I will just put this, the age. What statistics I need? I need outliers. I need percentile. Continue. What plots I need? I need histogram. I need normality plot with test. Continue. And what are the other options? No problem. And then I will click OK. So I'm exploring this particular variable in SPSS, and is the output. The output I'm searching for the just a minute. Now you can see the output of so age at baseline, there are 25 observations only, and the mean is 130, and the standard error of the mean is 9. 95% confidence interval for the mean is 111 and 149. Okay, so 5% trim mean means 5% of the data removed from the upper and the lower limit. Then the mean is 131. Median of the data set is 120. Variance of the data is 2082. Standard deviation is 45. Minimum is 36 month and maximum is 204 month. Range of the data is maximum minus minimum 168. Interquartile range is Q3 minus Q2. It is 60 month. And the skewness and curses are also calculated like this. The percentile, 5 percentile is 39, 64, 25 percentile is 102, 50 percentile is 120, and 75 percentile is 162. So this is the frequency distribution, highest and lowest. Now, what is this test for the normality? So here you can see the null hypothesis of this particular thing is said that data is normally distributed. And here you can see that it is both Kolmogorov-Simbrov test and Sapro-Weld test are suggesting that they fail to reject the null. So you can say that your data is almost normally distributed data. And you can say as that most of the points are lying near to these lines in the QQ plot. So your data is normally distributed. And this is the, what you can say, the box plot of the data. Okay. So once you have find out that your data is like this, so you can present your data with the help of the mean and standard deviation. So mean comes out to be 130 and the standard deviation of the data is 45 plus minus 45. Here you can see this. Again, I will repeat this. Just go to the descriptive statistics and then go to the explore, put the value of the variable. For example, if I also take follow-up duration, means कितने समय तक बच्चों को follow-up किया. This is the follow-up duration. Whether this particular variable is normally distributed or not. So I'll just click OK. So follow-up duration of 25 babies. So mean is 22. 20 for 20. And you can see that the maximum is 10 months, minimum is 10 months, and the maximum is 36 months. And for the testing of normality, here you can see the null hypothesis that the data is normally distributed, and Kolmogorov-Simrod test at 10%, it is saying that your hypothesis is rejected. But here you can see that how your data is, you can say that it is normally distributed by Sapro-Wilk test. And this is also suggesting QQ plot that your data is normally distributed. And this box plot is also suggesting that your data is very much close to the normal distribution. So if your data is normally distributed, you should present your data with the help of the mean and standard deviation. And tomorrow they will tell you that if your data is normally distributed, then you should use parametric test. And if it is not normally distributed, then you should go for the non-parametric test. So testing the normality of the data is very much important for doing the analysis. So here this analysis is descriptive statistics. Here you can use the frequency, descriptives, explore. So Toft analysis, ratio, PP plot, and QQ plot, but very important is this explore. So you can explore your the data by this. Similarly, if any of your data is a categorical variable, say baseline RACOLD RAI code, so yes or no. So you can simply go to the frequency and just click OK. So it will give you how many of them are yes, 17, and no, and in bracket the percentage is also given. So you can use this value and put it into your main paper. So in this way you can describe your data. For using the graph, you can go to the graph and then the legacy dialog. I told you that bar chart you can use, simple bar chart define for baseline at there you can see. Then click OK. So here you can see that the baseline bar chart you can also, and again in the graph you can also prepare the pie chart. Pie chart, and these are most of the time it is prepared for the categorical variable. Here you can see. Then one more kind of bar chart that I have discussed is the cluster bar chart. And this cluster bar chart here in the row, you have to put one thing. And it will give you the cluster bar chart like this. So once what the crux is that you have to understand the type of variable, and accordingly you have to summarize your data, or you should present, or you should provide the graphs according to the nature of the data. Blindly you cannot do anything. Okay. So this is from my side, and now the floor is open for question and answer.